This is the high-speed photometer, which was an instrument built at the University of Wisconsin Space Astronomy Lab and Space Science and Engineering Center as part of the instruments that flew on the Hubble Space Telescope. The Hubble Space Telescope is unique among astronomy satellites in that it's designed to have its instruments removed and updated. So that's why the Hubble is still flying in orbit and the high-speed photometer is here. This is one of the original instruments that flew on the Hubble Space Telescope when it was launched by the Space Shuttle and then released into orbit by the Space Shuttle. And the high-speed photometer, one of the first generation instruments, operated until the first service mission when the photometer was removed and replaced by a second generation instrument. This instrument was designed, it's called the high-speed photometer, because it was designed to take advantage of being in orbit in order to look at objects that change their brightness very rapidly. For example, rotating neutron stars that are sometimes called pulsars can flicker very rapidly, hundreds of times a second. And the Earth's atmosphere blurs those sorts of variations. But from in space, an instrument like the high-speed photometer can see those and allow astronomers to study what's going on with these compact objects, these rotating neutron stars. The Hubble Space Telescope and the high-speed photometer produced photometric measurements of the rotating neutron star in the core of the Crab Nebula, which rotates about 60 times per second. So that kind of rapid brightness variation could come from things like rotating neutron stars or from matter falling into a black hole, the disruption of a star in a galactic-sized black hole or something like that. So rapidly changing phenomena were what the high-speed photometer was designed to observe. It uses a series of photometers that you can see through our plexiglass panels. Originally those were metal. The actual light detecting instruments are these tubes right here, which are actually a century-old technology in a way that uses something called the photoelectric effect to detect light. And so there are detectors here which are highly advanced versions of century-old photoelectric light detectors. The Hubble Space Telescope holds 4 science instruments, which are called the axial instruments, right behind the mirror of the telescope. And so the Hubble Space Telescope's mirror, when the HSP was mounted in the telescope's mirror would be right out here, and there's a big hole in the mirror, and 4 instruments share looking through that hole. So the light from the telescope would end up coming through the hole and into the high-speed photometer this way. And then there are relay mirrors for some of the tubes. You can see the mirrors. The light comes down and bounces off of the mirrors and up into the image dissector tubes right here. So this is the optical assembly of the high-speed photometer, and the rest of the instrument carries the electronics that run all of this and control the environment of the instrument itself and communicate with the rest of the Hubble telescope control instruments. So the high-speed photometer was removed on the first servicing mission and brought back to Earth with the Space Shuttle, and ultimately made its way back to Madison here so that we can put it on display at UW Space Place.